Let's draw the Lewis structure of NO3-, recognized as nitrate. To accurately depict the Lewis structure of NO3-, follow these steps. Start with a rough sketch. Illustrate the chemical bonds between the atoms. Identify and mark lone pairs on the atoms. Ensure the central atom and others have a complete octet. Wrap up by calculating formal charges, aiming for a stable Lewis structure with the least formal charges possible. Before drawing the rough diagram, we'll start with two crucial steps. First, we will calculate the total number of valence electrons and then determine the central atom. The total valence electrons in NO3- are determined by summing the valence electrons of each atom. Nitrogen, from group 15, provides 5 valence electrons, and each oxygen, a group 16 element, contributes 6 valence electrons. With 1 nitrogen and 3 oxygen atoms in NO3-, the total valence electrons calculation is 5 for nitrogen plus, 6 for oxygen multiplied by 3, and an additional electron is included to account for the -1 charge of NO3-. This results in a total of 5 plus 18 plus 1, which equals to 24 valence electrons for NO3-. When determining the central atom for NO3-, prioritize placing the element with the lower electronegativity at the center. With nitrogen having an electronegativity of 3.04 and oxygen at 3.44, favor nitrogen due to its lower value. Consequently, for the initial sketch of NO3-, position nitrogen at the center and arrange 3 oxygen atoms on the periphery. 2 electrons represent a single chemical bond. First, position 2 electrons on the left side to indicate the chemical bond between nitrogen and the first oxygen. Similarly, place another 2 electrons on the right side to represent another chemical bond between nitrogen and the second oxygen. Finally, use another 2 electrons and place them on top to illustrate another chemical bond between nitrogen and the top oxygen. In this way, out of the 24 total valence electrons, 6 are utilized, leaving 18 electrons unutilized. Lone pairs consist of electron pairs not used in chemical bonding. Remember, each pair comprises 2 electrons. With 18 electrons remaining, we can form 9 electron pairs and mark them on the structure as lone pairs. Also remember that both nitrogen and oxygen are period 2 elements and cannot keep more than 8 electrons in their valence shells. One more thing to remember is to always start marking lone pairs first on the outside atoms and then on the central atom. In NO3-, each of the 3 outside oxygen atoms receives 3 lone pairs, while the central atom, nitrogen, won't receive any lone pair as we only have 9 lone pairs to mark on the structure. You can observe that the octet is complete on all 3 outside oxygen atoms, but not on the central atom, nitrogen. So let's now work on completing the octet for the central atom, nitrogen. Once again, remember that nitrogen is a period 2 element and cannot hold more than 8 electrons in its valence shell. Nitrogen already possesses 6 valence electrons and requires 2 more to complete its octet. Therefore, we will convert 1 lone pair from the left oxygen atom and transfer it to the nitrogen atom to form a chemical bond. Now, it is evident that the central atom, nitrogen, as well as the 3 outer oxygen atoms, all form an octet. Thus, the octet rule is satisfied, and now we can proceed further to check the formal charge to determine the stability of the structure. This is the formula we can use to calculate formal charges for the NO3- Lewis structure. Formal charge equals valence electrons minus non-bonding electrons minus half times bonding electrons. Enter the necessary data and place the values to derive the formal charges for each specific atom. For nitrogen atom, valence electrons are 5, non-bonding electrons are 0, and bonding electrons are 8. So the formal charge will be equal to 5 minus 0 minus half times 8, which equals to plus 1. For left oxygen atom, valence electrons are 6, non-bonding electrons are 4, and bonding electrons are also 4. So the formal charge will be equal to 6 minus 4 minus half times 4, which equals to 0. For top oxygen and right oxygen atom, valence electrons are 6, non-bonding electrons are also 6, and bonding electrons are 2. So the formal charge will be equal to 6 minus half times 2, which equals to minus 1. The formal charges of both nitrogen and oxygen atoms are mentioned, indicating that formal charges on atoms are closer to 0. Therefore, this structure is the preferable, most stable Lewis structure of NO3-. To represent a pair of bonding valence electrons, we can simply draw one horizontal line. On the left, there are 2 pairs of electrons, so draw 2 horizontal lines. On the right and the top, since there is 1 pair each, we will draw 1 horizontal line in each place. Since NO3- is an ion with a negative -1 charge, we will draw brackets around the whole Lewis structure and indicate the charge on the top right corner. That's the Lewis structure of NO3-. If you found this explanation helpful, show your support with a like, share the video, and subscribe to the channel.